Good afternoon, everyone. Thank you for joining us for our spring webinar. My name is Julia Severi. I'm from Cesar Australia. I'm joined by Lilia Jenkins, also from Cesar Australia, and Cesar Australia's Director, Associate Professor Paul Yamina. Just a bit of an overview of what we're going over today. We will be mostly talking about aphids in the context of the recent warm August that we've had, but recognising that other insects are likely to be impacted by recent warm weather. I'd also like to touch on Etiella, and there'll be also opportunity to ask about any other insects that you'd like to talk about. I'm going to go through key aphid species that you should be monitoring this spring. We'll touch on aphid thresholds where available. And Lilia will be giving you an insecticide resistance update on blue-green aphid. And also she'll be talking about the beneficials chemical toxicity table. There is a question and answer box for you to enter questions. I encourage you to enter those questions as we're talking and we can address them at the end. This webinar is organised through our Pestfacts Southeastern project, which is supported by the GRDC project Seasonal Status of Pests Delivered to Growers. So as a Southeastern project, we will be focusing on Victoria and Southern New South Wales. So yes, we've had an unusually warm August. Victoria, for most of August, was the highest on record for mean temperature deciles. And also New South Wales experienced for a lot of it highest on record. And if it wasn't highest on record, it was very much above average temperatures. And we recognise that this is a big factor in the development and also the activity of insects. And you may be starting to notice that already in your crops. We'll mostly focus on aphids, but I just wanted to briefly touch on Etiella lucerne seed web moth because it's a good case study to show how that warmer August can impact some of our common spring pests. So if you're not familiar with Etiella, they're not active during winter. They're overwintering in the soil. And then come August, sometime in September, the adult moths emerge. And then the females will lay eggs on the leaves, stems and flowers. And then the larvae will hatch and they will bore into the seed pods. So it's one of those very few pests that in terms of control, we have to target the adult moth before egg lay. And Etiella predominantly affects lentils and lucerne, but it can also be found in lupins, field peas, peanuts, soybeans, vetch, medics and clover. Now we can use the SARDI degree day model to predict when those flights will be active to help monitoring efforts and achieve like a well-timed spray. So this model, it's available at etiellaModel.app, and it uses maximum and minimum daily temperature data from June 21st onwards. At a given location, you input that location and it will forecast the flight activity of Etiella moth. At 300 degree days accumulated, it's recommended that you start monitoring. And then at 351 degree days, it's estimated that you'll have the peak moth flights. So that's 10% predicted of onset of peak flight activity. So you can compare the predicted moth flights from over the years. And if we compare last year to this year, we can see the effect of that warm August. So in 2023, last year on the 15th of September, we would have been at 292 degree days, but this year we're at 359. So that warm August has meant earlier moth activity by about 10 days. So we've actually passed recommended monitoring and passed peak moth flights commencing. This is for horsham. We're not quite at monitoring stage yet, but you can see that the moth activity is likely to be earlier this year also. Similar with Elmore, earlier moth activity. And Wagga Wagga, earlier moth activity, slightly earlier, and probably by now it's going to be recommended to start monitoring and approaching peak moth flights. So that's just a little case study to show how that warm August can impact activity between the years. So moving on to aphids, that milder August will also likely impact aphid activity. It will impact the development. You'll get, how quickly they're reaching adulthood will increase. And then you also get the high temperatures will favour mobility. So you'll probably get a higher number of winged individuals and also increasing their flying capacity with that increased or that warmer August. I'll just briefly touch on the key aphid species that could be around this spring, and I'll touch on their thresholds where available. And I just want to make a few notes before that. Most of the aphid thresholds that we have available are nominal, they're not dynamic. So they're based on the insights of experienced consultants and researchers over the years. They don't take into consideration factors such as grain prices, insecticide costs, what beneficials you have around. So they're best used as general guidelines. Also keep in mind that crops that aren't moisture stressed have that ability to compensate for aphid damage. Also, aphids are known to sort of flock to plants that are already under stress. So keep that in mind. If you're finding aphids and you think they're causing damage, are they the primary issue, or could it be that there's something else going on and aphids are sort of just taking advantage of that stressed plant? So looking at canola, the two aphids that could be popping up during spring, we've got cabbage aphid and turnip aphid. Now these are the two species that tend to colonise quite densely on the growing floral parts and the pods of the plant. You might still find green peach aphid at this time of year. However, they tend to be located more so underneath the leaves and the foliage in the lower canopy. We have seen them move on to pods, but this tends to happen in more, it can happen in drier years or when plants are stressed. I'm not sure why this happens or really how much of an impact it would have, but they don't appear to colonise as densely as a cabbage aphid or a turnip aphid would. So yeah, I just wanted to recognise that, while we do say they are found under the leaves, you may see them creep up onto the pods, but the way they're colonised doesn't seem as concerning as with a cabbage aphid or a turnip aphid. So cabbage aphids are quite the sort of bluey to green in colour. They often have this white wax on their bodies, have a powdery white appearance. Turnip aphid, sort of olivey green in colour, can also have a little bit of a white appearance, although not as thick as a cabbage aphid. Then we've got green peach aphid. Doesn't have that sort of whitish coating that a cabbage or a turnip aphid would. They are more sort of green, shimmery looking in colour. And you might also find that they vary from green. Just this year, we've had some pink green peach aphid spotted in canola, so that's not uncommon. So the threshold for aphids in canola for cabbage aphid and turnip aphid is more than 20% of canola plants infested with aphids. For green peach aphid, there aren't any thresholds. Like with direct feeding, it would likely take very, very extraordinarily high numbers for them to impact advanced canola. And traditionally with green peach aphid, we worry about them as a vector of turnip yellows virus. But at this time of year in advanced canola, the risk of the effects of turnip yellows virus has diminished. So we shouldn't be, in general, as a rule of thumb, spraying for green peach aphid in advanced canola. If you're sowing spring sown canola at this time of year, that's a different story. They could still be at risk of turnip yellows virus. So if you are considering spraying, don't forget we do have issues with insecticide resistance. And Lilia's going to touch on that in just one moment. But I just also wanted to point out that with springstone canola this year, cabbage aphid and turnip aphid aren't concerns with transmission of that virus. I'm just going to pass it over to Lilia. She's going to talk about resistance in green peach aphid for just a moment.
Yeah, beautiful. So throughout Australia, it's fairly well known that we have high level resistance to a lot of the broad spectrum chemicals that we use to control green peach aphids. So these are like your synthetic pyrethroids, your carbamates, and they're quite widespread. There's also widespread low level resistance to organophosphates and neonicotinoids. So whilst the resistance in these is lower, they can still have impacts on control. So with the resistance to neonicotinoids in particular, the worry is that it can reduce the efficacy of seed treatments. So whilst, rule of thumb, you might get like anywhere between 5 to 8 weeks depending on what type of seed treatment you're using. With neonicotinoid resistance, you do see that the plants become susceptible to green peach aphid colonization a little bit earlier. So you just need to make sure that you're really monitoring throughout that establishment period as well. We do also have some new resistances to keep an eye out on as well. So resistance to spirotetramat was detected in 2022. And we also know that there's also low-level resistance to sulfoxaflor or transform. The good thing here is that the resistance to sulfoxaflor is still low, and it means that it is still effective in most field populations. You just need to be wary, especially in dense canopies, that you might need to use the higher label rate. And the really good thing is that with flunicamid and aphidopyropin, which are more selective chemicals as well, meaning that they're more compatible for IPM systems, these still remain effective and there's no current resistance detected there.
Great, thanks Lilia. Just going to zip through cereals and some pulse aphids. So in cereals, you're probably going to see mostly oat aphid around. They tend to be the most numerous aphid in cereals at this time of year. But you could also see some corn aphid. From the photos that I've been sent in, it's quite hard to tell them apart because they're quite similar in appearance. But if you need to tell them apart, the oat aphid has a red patch along the lower base of their abdomen, whereas corn aphid just has sort of dark patches around each of their siphunculæ, those exhaust pipe structures, but management for those two is very similar. You might also see some Russian wheat aphid this time of year. We haven't heard a lot about Russian wheat aphid, but if you've experienced otherwise this year, please do let us know. And I just wanted to point out that if there is an aphid that's going to be confused with Russian wheat aphid, it would be the rose grain aphid. It's not common, but it does look most similar out of all the cereal aphids. And how you tell them apart is the rose grain aphid has a line down the middle of its back and it has visible exhaust pipes, and which the Russian wheat aphid exhaust pipes aren't visible. And another aphid that could be around this time of year is the rice root aphid. It looks very similar to oat aphid. They have that red patch at the base of their abdomen. However, they tend to be more of a yellow colour, and their antennae kind of sit like bull horns. You can see there in that photo. Rice root aphid is a root aphid, but they can creep up the plants. Just a couple of images of some reports we've received of oat aphid this year. Yeah, quite high numbers, but yeah, interestingly, the photo there on the left, they took a sort of watch and wait approach, and they haven't had to spray at this stage because the beneficials do seem to be getting on top of those aphids. Thresholds for oat and corn aphid is more than 15 aphids per tiller for 50% of tillers if the expected yield will exceed 3 tonnes per hectare. And you may even notice with oat and corn aphid that they will decline as the crop comes into head. And if you are spraying for these aphids, it should be for your concern of the direct damage from feeding alone, for the direct feeding damage. It's just not warranted at this time of year to be spraying for an potential effect of barley yellow dwarf virus with these two aphids. If you have, just a reminder, if you do have Russian wheat aphid, we do have a dynamic threshold calculator for this species, and it can be used between growth stage 30 and growth stage 50, and that's available on our website. These are the 4 species most likely to occur in pulses in southeastern Australia. We've got blue-green aphid, pea aphid, cowpea aphid, and favour bean aphid. The 2 species that are most likely to be confused is the blue-green aphid and the pea aphid. They're really closely related in the same genus. There are some ways that you can tell them apart, but for the purpose of looking at them in the field, generally pea aphid is quite a large aphid. It's bigger, about 1 to 1.5 millimetres bigger than a blue-green aphid, but they are similar in colour, sort of bluey-green. Sometimes pea aphid can have a bit of a pink morph. Cowpea aphid and favour bean aphid, you're unlikely to get those confused with anything else. They're quite unique in their appearance. Cowpea aphids, black in colour, quite shiny. The nymphs are a little bit more matte grey looking. Favour bean aphid's quite a striking aphid. It's got a green body, black head, black exhaust pipes, black tail, black legs. And if you look close enough, you can see these sort of vibrant, bright red eyes. Still a relatively new aphid in southeastern Australia. You may not have experienced it in your favour bean crops or your vetch yet, but you might see it around this year. And very limited thresholds for aphids in pulses. We've got blue-green aphid, pea aphid and cowpea aphid. For lupins, we've got 30% of flower heads infested with 30 or more aphids. And then for blue-green and pea aphid in favour beans, we've got 10% of plants infested. And I did want to mention that it's important to tell blue-green aphid and pea aphid apart, because blue-green aphid has started developing resistance. And I'm going to pass it over to Lilia now, who's going to talk about that.
Beautiful. Thanks, Julia. Just let me pull it up. Perfect. So, like Julia said, I'm going to be speaking about insecticide resistance and blue-green aphid and the current research that we're doing here at Cesar Australia. Whilst I'm the lead communicator on this project, all the research is actually led by Everett Chirkwin. So, like Julia mentioned, blue-green aphid is a pest of lucerne, pulses, medics, clovers, and pastures. It damages through direct feeding, obviously, as well as a little bit of virus transmission. It's very common in spring, so we're coming up to the critical monitoring period for the pest now, and we want to start to think about how we're going to control it. Traditionally, chemical control is, the typical way that it would be controlled, but newfound resistance is beginning to make this a little bit more difficult. So in 2021, Cesar Australia with Lucerne Australia did discover insecticide resistance to several of the major insecticide classes used to control it, including, again, those broad spectrum ones like carbamates, organophosphates, and synthetic pyrethroids. Initially, these were identified only in South Australia and New South Wales, but by 2022, the resistant populations were then found in Victoria, and new resistant populations were also discovered in New South Wales, so it was beginning to spread. Then in 2023, it confirmed that it was not only affecting lucerne crops, but it had also spread to clover and lentils. So to break this down a little bit more, resistance does remain a really common problem in lucerne paddocks. So we see that most blue-green aphids collected from South Australia lucerne shows particularly high frequencies of resistance. And new resistant populations continue to be discovered, including across the southeast, mid-north, and the Erie Peninsula regions. While there are still some susceptible aphid populations being found, and whilst this means that chemicals might still provide adequate control, the overall effectiveness is becoming more and more inconsistent. The good news is also, at least, that the current magnitude of resistance is consistent, meaning that they're not evolving a higher level of resistance over time. It's just sort of spreading more across the states. So the big news from this year is that for the first time, we now have evidence of resistance to all of those key insecticide groups registered for control in Victorian lentil crops. So in previous years, testing in Victorian lentil crops didn't show any signs of resistance. So this suggests that this is a recent development, and it's a particular worry because it leaves growers with really limited control options. And this is where it becomes really important to understand resistance in your location, as your chemical control options do vary by crop type and which state you're in. So for example, Ovento, which is Spirotetramat, it's currently approved under emergency permit for use in lentil crops in South Australia, but it's not yet available or registered to use in Victoria. So if you find blue-green aphids, what can you do? Firstly, use of organophosphates and carbamates in particular should be avoided where possible, because by continuing to use them and rely as heavily on them as we do, it's continuing to exacerbate the resistant issues. So sulfoxaflor or Transform is registered for use in lucerne and in some pulse crops. And as I mentioned, Spirotetramat is under emergency permit in South Australia. When chemicals must be used, especially those above ones where we know there is resistance, it's really important to continue rotating through the different modes of actions to help minimize the risk of further resistance evolution. We also really recommend consistent monitoring when you can, and using those action thresholds we talked about to inform spraying decisions. And as noted, there are also those other aphids that target the same crops. So those are things like the cowpea aphids, spotted alfalfa aphids, and pea aphids. So knowing what type of aphid you're actually dealing with can help guide what chemicals are the most effective to use. We do also know from surveys that there is a parasitoid that helps control blue-green aphids. This is Aphidus cervi. We've naturally found really high levels of parasitism by this parasitoid across 25 locations in all states, and it covers like clover, lucerne, vetch, and lentils, so all your main crops. So if you're experiencing an aphid outbreak, it's really important to check what parasitoids and your beneficials are doing. So you can do this through sweep nets or checking for those aphid mummies, which are the sort of bronzed, swollen aphids. And if you see really high parasitoid activity, which it does continue to increase during spring, you might consider your spraying options a little bit more. The same sort of goes for your more generalist predators. So again, we've identified that the predators like rove beetles, spiders, ladybird beetles, and lacewings do target BGA as well. So all of these beneficials can help potentially keep blue-green aphids under threshold levels. The sort of main caveat here is that beneficial insects are often sensitive to chemical sprays. And that's where the beneficial toxicity table comes in handy. And you can use that QR code there that will take you to a link to it on our website. And it's really useful to make informed spray decisions. And this leads me on very nicely to my next talk, where I'll just explain the table a little bit further. But I did just want to briefly acknowledge that this work is supported by AgriFutures Australia and GRDC in collaboration with Lucerne Australia, and it's been supported by a wide range of people, including other researchers, as well as growers and agronomists. I've also popped down Everett Turgwin's email there, so if you have any questions or you're suspecting resistance, you can always send him an email. So onto the beneficials toxicity table. So as mentioned, obviously, IPM is really useful for controlling pests on your farm in sort of a synergistic, holistic manner. But the main issue when it comes to integrating beneficials in grain crops in particular is that they can be sensitive to chemical control. So as a result, we sort of lose the natural pest suppression that these guys provide. So what we really needed was better information on how we could better integrate both of these control methods into our systems. We did have a lot of this information across many farming systems, especially in like horticulture and cotton, but in grains, previous to one of our projects, there was no integrated scientifically proven guide to the toxicity of these really common chemicals. So that's where the project called AgPIP came in, and we basically put together a reference guide that sort of helps break down the effects of spraying with a particular chemical on the existing population of natural enemies. So this is the table as it currently stands. Like I said, you can find this on our website. We also have it available on agpest.com.au, and that version is actually interactive. So you can click into each chemical. It explains a little bit more about what it does. You can see what the beneficials actually are and what they target. So it's really useful if you want a little bit more information. So it was first published in April and it has been updated in 2024 as well. And it sort of just summarizes the impacts of all these different active ingredients on a range of beneficials, from your generalists like your lacewings to your specialists like your parasitoids. It was developed in consultation with growers and chemical industry representatives. So we make sure that we focused on the actual chemicals, the field rates, the growing environment, and the pests and beneficials that were actually specific to the grains industry. The ratings were determined by averaging the results across chemicals and insect species, and you can see here that it's arranged in a descending order, so it's really easy to use. The least toxic chemicals are at the top of the table, and then they progress downwards to the more toxic ones. And it's sort of like a traffic light system, so the ones with the least impact are green, those with moderate impact are yellow, those with high overall impacts are orange, and then those with a very high impact, red. If you see any with the split ratings, that means that there's just sort of a wider range. So in terms of breaking down specific findings from the research and how we can use that to better manage aphids, the most obvious one is obviously that more selective chemicals had lower mortality rates. So those were things like your flunicimid and your Aphid. We also found that some beneficial groups were sort of broadly tolerant. So these were, again, sort of your generalists. So things like your lacewings, hoverflies, spiders, and rove beetles. You can see that in general, they were a lot hardier, I guess, to a lot of the chemicals. But again, particularly the softer, more selective ones. So in specific terms of aphid management, obviously we know that a huge range of insecticides are used, from broad spectrum to those more selective ones. We know that parasitoid wasps and predators can help keep numbers below thresholds. But again, the issue was just that really specific information is how they actually interact in the field with chemicals. So whilst pyrimecarb was often thought to be a more selective option compared to like your synthetic pyrethroids and organophosphates, what we actually saw through the research was that pyrimecarb still had a really high mortality rate for a lot of those parasitoids, especially again compared to flunicimid and Aphid, which are much more compatible for an IPM system. So when it comes to using the table for management, you can use it to support how to reduce the impact on beneficials when possible. So you can use it to make chemical choices for specific pests and beneficials, or you can also just use it to make an overall choice for the least toxic chemical if you're not actually sure which pests or which beneficials you have in your system. So again, just a quick acknowledgement to all of the AgPIP team. The AgPIP was again supported by the GRDC along with the University of Melbourne, and was worked on by a huge range of really amazing scientists. Yeah, that's about it. Thank you.
Okay, do we have any questions? So someone's asking the presentations be made available online, please. Yes, I can. We are recording this and I can publish that on our YouTube channel, and I'll send out a link to our Pestfacts Southeastern subscriber base when that's available. I've got a question here. Are the models saying Etiella are at peak movement in Witchyproof and Charlton area? So what I'd encourage you to do is I'll go back to that slide on Etiella. If you go to this website, it's the Sardi degree day model, Etiella model.app. And here you'll find like a GPS map, and you put in your coordinates, and it will take the closest weather data and give you a result for your own location. So I haven't run the model myself for those areas, but I encourage you to use this app to do it for your location. So, which were the 2 chemicals still registered as effective for green peach aphid?
So the chemicals that we don't have any resistance in, so that's sulfoxaflor, which is transform, well, it has low level resistance, but we do still know that it is effective in field. And then we know that there's no resistance yet to aphidopyropin or flunicamid.
Excellent. So I've got a question. Is there any ongoing resistance work happening this season? Paul, maybe you can speak to that.
Yeah, as Lilia mentioned, there is a project that we have funded through GRDC looking at, I guess, this relatively new resistance that's popped up in the last few years in blue-green aphids. And so certainly if you suspect that you may have resistance, if you experience a chemical control failure in one of those pulse crops and you think it's blue-green aphids, then yes, please do get in touch with Aphid or Lilia or someone else at Cesar Australia, and we can talk to you about how to undertake a resistance test on those populations. There is no active, I guess, resistance testing on green peach aphids right at the moment, but I guess hopefully there will be in the near future. But again, at this time of year, outside of spring sown canola, I don't think green peach aphids are probably a pest that you're going to have to be dealing with from a chemical perspective. I guess in those forage brassica crops and spring sown canola, they may certainly pop up, but no resistance testing at the moment for that species.
And we've also had a question about viruses in canola and cereals, about what are seed treatments doing for us time-wise, and about economic thresholds, because they're usually so low, it's hard to make a spray decision to prevent the disease in the case of aphids when they're present earlier on.
I'm happy to talk to this point. This was obviously a conversation that we had regularly earlier on in the season, particularly with growers and agronomists in southern New South Wales, where there was quite a lot of turnip yellows virus detected in canola, both winter sown and spring sown canola crops. And certainly seed treatments are an important tool in keeping green peach aphids out of crops during those first few weeks of establishment. But as Lilia mentioned, unfortunately, a lot of the green peach aphid populations now in Australia do have resistance to our neonicotinoids. And so I guess we perhaps don't have the same level of confidence that those seed treatments will provide a long period in which green peach aphids will be, I guess, prevented from colonising and starting to probe canola crops. And so the seed treatments are an important part of that, but of course they wear off as the plant grows. And ultimately, early intervention with chemicals is critical when it comes to minimising risk of turnip yellows virus coming in and spreading in canola crops. At this time of year, as Julia mentioned, for our crops that are obviously well established, the common thinking from virologists and all the research suggests that once those canola crops get beyond the rosette stage, so starting to get into stem elongation, that the impacts of turnip yellows virus on canola are fairly negligible, and there's probably not a need to go in and intervene with chemicals to control green peach aphids in those late stage canola crops when thinking about turnip yellows virus. The infections can still occur, of course, late in the season, but the virologists are very confident that those very late stage infections are not going to impact either yield or seed quality. Of course, as Julia mentioned, if we're sowing canola crops over the coming months, clearly there's a risk of early infections occurring in those crops. And so certainly, the seed treatments will be an important part of that, but absolutely, I think critical will be monitoring those crops during those first few months, and I guess being cognizant that there is quite a bit of turnip yellows virus around in the environment at the moment.
Thanks, Paul. We've had another question. Do we know of any work being done on how many beneficials are needed to keep control of aphids? I'm not aware of any of this work myself.
There is some work. I think that was a comment from Phil. Yeah, no, there is some work going on, and this is something that GRDC funding some projects looking at this particular question. And it is certainly a very important question, but a very complex question. And so, no, there is a little bit of work going on. I don't think there's any early evidence yet or early indications yet of exactly what that looks like. But we certainly know that in the context of aphids, there is a real opportunity to better utilise beneficials, the parasitoids and the predators that Lilia spoke about. But of course, we do need to understand that critical question of how many beneficials do we need? And of course, again, that's a very complicated ecological question. We're working, there's many other groups, CSIRO and state agriculture departments, that are working to try to unpack that and try to, I guess, ultimately identify some tools and some simple ways in which we can help growers and advisors with that decision making around beneficials, because they do provide a really important role. We just don't know how important that role is, and of course that role is going to be highly variable from season to season and crop to crop.
Thanks, Paul. We're just at time now. I just wanted to bring up our final slide again. This is our Pestfacts Southeastern mobile number that you can contact our Pestfacts team directly on, 0484 310 697. If you haven't already, I encourage you to save it in your phone. We've also got a Pestfacts Southeastern reporter app that you can get on Google Play or the Apple App Store, or through email you can contact us. Just 3 ways that you can keep in touch for the remainder of the season. Feel free to keep the questions coming if there's anything that you think of after this webinar, or if you encounter any pest issues or observations that you want to share with us for the remainder of spring. So I think I'll leave it there for now. Thank you for joining us. And as I said, I will send out the link to this recording when it becomes available online. Hope to chat to you soon. See you for now.